All right, so starting with number 7, and I'm going to grab a blank piece of paper to write this on now, because I know it's going to take up a lot of room. So we have x plus 3 divided by x subtract 4 over x subtract 1 all over x plus 1, x plus 1 over x subtract 1. So first we got to do our common denominator, multiply it out, and then compare. So our common denominator is going to be x times x minus 1. Since this one's over x, I'm going to have x plus 3 times x subtract 1. And then all that's going to subtract 4 times this x. And all of it's over x times x minus 1. I didn't leave myself enough room to write this over here, but we're going to do it anyway. Actually, go ahead and... So we have x plus 1 times the denominator x minus 1 plus x plus 1 times this x all over x times x minus 1. Goodness, doesn't that make you excited? Okay, so we FOIL this out. X times x is x squared subtract x plus 3x subtract 3 subtract 4x over x times x minus 1. Now then I'm going to flip this part. So I have x times x minus 1. This would be x squared subtract x plus x subtract 1 plus x squared plus x. Now then, combining like terms, I'd have x squared negative 5 plus 3 would be negative 2x subtract 3 over x times x minus 1 times x minus 1 over, that's 2x squared, those canceled, plus x subtract 1. All right, now that I have to factor these factors of 3 that subtract to get 2 would be 3 and 1, so I have x subtract 3 times x plus 2 over x times x minus 1. All right, factors of 2 that subtract to get 1, so 2x, x, one a negative at the end, so one of these positive, one of these negative. I have positive 2, so I'm going to have positive 1 here and negative 1 here, because that would give me my positive 2x subtract x to get that positive 1x. Cancel. Really? These don't cancel. Okay. This cancels with this. Wait. It's not 3 times 2, it's 3 times 1. Now let me check. X squared plus x subtract 3x subtract 3. And these two would cancel. So that's one way to always check these, because they're having you do this to cancel things out. So if you can't cancel something out, you might have messed up. So x minus 3 over 2x subtract 1. And I need to put 7. Okay. 8. So we have to get our common denominators first. So right here, our common denominator is going to be x. So we have to multiply this 5 by x. So we'd have 3 plus 5x over x. Same thing down here. This one's already over x squared, but we have to multiply the 25 by x squared. Now then, this is the difference of two squares, so it's going to factor out more. And I'm going to go ahead and write this. So 3 plus 5x over x, and this, the square root of 9 is 3, and the square root of 25 is 5. So we're going to have 3 subtract 5x subtract 5x over 3 plus 5x. Because it's the difference of two squares, they have to have the opposite signs. So when we go to multiply these out, the center will cancel out. So our 3 plus 5x. Then we have x squared and an x. Remember when we did our exponent rules, the quotient rules, so it'd be 2 subtract 1. So we'd have a positive 1. So our answer is going to be x over 3 subtract 5x. That one didn't take up that much room. Number 9. So we have negative 5x divided by x subtract y all over y divided by x squared. So there's nothing we can factor on this, so that's positive. So negative 5x over x subtract y. Change, then flip x squared over y. And then we'd multiply across. So we'd have negative 5x times x squared. So negative 5x cubed over, I don't know if we have to multiply this one out or not, so we're going to have y times x minus y, which would be negative 5x cubed over xy subtract y squared. So negative 5x cubed over subtract y squared. Draw some lines on here. Okay, so we have 3 divided by x plus 4x squared. We're going to have the common denominator there, all over y divided by x squared. So our common denominator on the top is going to be x squared. So what do I have to multiply x by to get x squared? It's x, so I'd have 3x plus 4 here. And all of that is going to be over y divided by x squared. So when we keep the top, change to multiplication, flip the bottom, our x squares are going to cancel, and we have 3x plus 4 divided by y. And that does not reduce, so. Okay. Here, this is the difference of two squares, so this is x minus 2 times x plus 2. Right here, we have 1 on the outside, so you have to multiply that 1 by x minus 2. So we'd have x subtract 2 plus 1 over x subtract 2. We're going to combine those terms when we go to flip this. So I have x subtract 1 over x subtract 2 times x plus 2 times x minus 2 over x subtract 1. So our x subtract 2's cancel, our x subtract 1's cancel, and we're left with nothing on the top, so it would be 1 over x plus 2. All right, last one. So on this one, it has these negative exponents, and what I want you to remember about your negative exponents is only turn them to positive exponents. So this x to the negative 1 would be 1 over x. This x to the negative 2 would be 1 over x squared plus 1 over y squared. So I just did the negative exponent rule to change those. Now then we have to find the common denominator of the denominator. So our top is good to go, but let's do this. So our common denominator is going to be x squared y squared. So I have to multiply by y squared over here. So we have y squared plus x squared. Now we're going to flip this. So we have 1 over x times x squared y squared divided by y squared plus x squared, but it's addition, so the order isn't particular. Right here, we're going to use our quotient rule with these since they're multiplying. And so to subtract 1 would be 1. So we're going to have x y squared over, I'm just changing the order of this because it bothers me, but it should take it either way. So x y squared over x squared plus y squared. I feel quite tongue-tied after that, but that is all.